A student has sent me an email asking about a question from the quiz. It's about monopoly, price and quantity. The question is this: consider a monopolist facing a demand curve given by P equals 20 minus Q, where P is the market price and Q is the quantity sold. The monopolist's marginal costs are MC equals 2 per unit. There are no other costs. What are the monopolist's profit maximizing price and quantity? Okay, you already know before you go any further that the profit maximizing output is where marginal revenue equals marginal cost. Okay? That's that. We know that before we go anywhere else. And after you've established what that profit maximizing output is, then you can find the price at that profit maximizing output. So we're starting off with this equation which is representing a demand curve. Right, so it's price equals 20 minus the quantity demanded. Now what you'll recognize is that this is actually has the form of a linear equation which you'll remember from high school, which is y equals a, well, plus or minus b multiplied by x. So we've got the y is the variable on the vertical axis, like this. X is the variable on the horizontal axis, like this. A is the vertical axis intercept, like this. And B is the slope of the line, so the rise over the run. Okay, so rise over run. This, and it's a straight line, so rise over run at any 2 points will give you the slope, which we're representing here as B. Note that it's a negative sign, indicating that it is a downward sloped demand curve, or curve. Now in this case, all we've done is just have these here. Instead of Y, we've got P. Instead of A, we've got 20. Instead of X, we've got quantity. And instead of B, we've got what? Well, where is the B or the slope here? Well, it's there secretly. It's the number 1. Bloody hell. It's the number 1. Okay? Normally, obviously, we don't write in 1 times something, a quantity. It's just going to be equal to that quantity. But nonetheless, it is there. So the slope is 1. Alright? So if B equals 1, and we know that the vertical intercept is 20, then we know that the horizontal intercept is going to be 20. Because that's what gives us 1 over 1, which is 1. Okay. Anyway, let's move on. If we wanted to draw this equation in the graph, P equals 20 minus Q. So we know what the vertical intercept is going to be. It's going to be here, 20. So that's here. And we also know that the slope is 1. So it must be the case that the rise over the run is, if the rise is 20 and this is 1, then it must be that the run is similarly 20. Okay, so we've got our vertical intercept and we've got our horizontal intercept, and we know that this is a straight line. So easy, we're just going to do something, something like that. In fact, let's do that more precisely. Our next question is, remember what we're ultimately aiming to get to is where marginal revenue equals marginal cost. But we need the marginal revenue curve. Now, that's actually nice and easy. We can do that in a quick and dirty way because we've got our downward sloping demand curve or average revenue curve, and we know that the marginal revenue curve will be twice as steep. So it will start at the same point, but it will fall twice as fast, which means if it falls twice as fast, we have to find halfway along here, and that will give us, voila, our marginal revenue curve. Alright, halfway home. Remember our goal, find output where marginal revenue equals marginal cost. So we need the marginal cost equation. Remember, we were given that in the question. Marginal cost equals 2 per unit. So it's at every level of output, marginal cost is 2. Alright, so it'll be here. Marginal cost is 2 at every level of output. Like this. There's our marginal cost curve. So, where is the optimal output? Where marginal revenue equals marginal cost. Where is that? Here. So the optimal output for our firm will be 9 units, and they will charge the highest price consumers are willing to pay, obviously, which is $11. Voila, you've got the answer to the question. Price is 11 and the quantity is 9. Alright, that's one way to do it. If you don't want to know the longer way, then that's fine, you can stop here. But for those intrepid souls who want to go on, let's do that. If we remember, we want to find, right, our goal is marginal revenue equals marginal cost. Where's the output? At what output? Okay. So we want to find marginal revenue. So we don't have an equation for marginal revenue, so what we need to do is we need to get to marginal revenue through total revenue. Why? Because marginal revenue is the change in the total revenue. If you remember what marginal revenue means, it means the additional revenue earned from selling an additional unit of output or an additional increment of output. So it's the amount you're adding to your total revenue. So to get to marginal revenue, we've got to go through the total revenue. So what's our equation for total revenue? Price times quantity, as given there. Price times quantity. And now you'll remember we can expand out the price part of this equation because we've been given this equation for price. 20 minus Q. It's 20 minus 1Q really, but nonetheless, there we go. So we can substitute this into the price part of the total revenue equation, like this. And then we can expand the brackets. So multiplied by Q to give us this. 20Q minus Q times Q is Q squared. So total revenue can be rewritten like this. Alright, so far so good. Now what we need to do is something a little bit trickier. We want to make explicit our powers. So we already know that this is squared to the Q to the power of 2. We know that. But we also have to remember that really, even though we're just writing the Q here without any power attached to it originally, in fact, it secretly has Q, it's Q to the power of 1 secretly. But since Q to the power of 1 equals Q, there's no point normally putting in the to the power of 1. But nonetheless, we want to make it explicit now, because we're going to need to know that. Alright, now what we need to do is to take the derivative of this total revenue to find R prime, or this is a shorthand for marginal revenue. Alright, so we need to do some basic calculus here. So we're going to do the quick and easy version of the basic calculus. So the first step we're going to take is this, in order to get to the marginal revenue equation through the total revenue equation. First, what we want to do is take the power and put it down the front, multiply it by the front, and take the power, multiply it by the front, like that. That's the first step. The next step is we want to then deduct 1 from the powers. Okay, deduct 1 from here, 1 minus 1, to give us 0, and 2 minus 1. Okay? So then we're left with this thing here. 20 times quantity to the power of 0. So some quantity, something to the power of 0, is equal to 1. Minus 2 to the power of 2q to the power of 1. And q2 to the power of 1, you don't need to really have the 1 there. You can just write it as q2. So we got this. Alright, because that is multiplied by 1. Alright, so 20 multiplied by 1 gets 20. Fine. And this is our marginal revenue equation. That is our marginal revenue equation right there. Okay, so we've got these 3 equations. We've got the demand equation, we've got the marginal revenue equation, and we've got, as per given in the question, the marginal cost equation. So the C prime, or the total cost prime, is sometimes used to indicate marginal cost. Now, we know that the profit maximizing output, which I'm going to call Q pi, to indicate this is the profit maximizing output, it's not just any old output, is where the marginal revenue equals the marginal cost. So, in order to find where this quantity is, we want to say that whatever that quantity is, it must be true that this is equal to this. Yeah? Marginal revenue equals marginal cost, like this. Okie doke. Right, so this Q is representing the profit maximizing quantity. Now we just want to rearrange it. Okay, so we'll take this guy and we'll put it over here. So we got this. And then what we'll do is we'll take this guy and we'll put it over there. And then what we'll do is we'll take this guy and we'll put him over here. And there, voila. The profit maximizing output is 18 over 2, or 9, as we saw in the graph previously. Alright, so that's the profit maximizing output. But what's the profit maximizing price? Well, the profit maximizing price is whatever the price is at this profit maximizing output. So we can simply take that output and plug it back into this equation here to find what the profit maximizing price must be at that output. So we've got price equals da da, and we're putting in the price, the profit maximizing output, which we worked out was 9, and then it's straightforward. The profit maximizing price was 11, just as we found when we did it with the graph. And that is that.